Hello there, welcome to our video on black holes. In this video, we're going to explore one of the most mysterious and fascinating objects in the universe. So, what is a black hole? Simply put, a black hole is a place where gravity is so strong that nothing, not even light, can escape. It's like a giant vacuum cleaner in space, sucking in everything that gets too close. Now, you might be wondering why black holes are important. Well, not only do they teach us about the extreme conditions of the universe, but they also play a crucial role in shaping the universe as we know it. Black holes are like cosmic engines, powering some of the brightest and most energetic events in the universe. In this video, we'll explore the different types of black holes, how they're formed, and the properties that make them so unique. We'll also delve into the mystery surrounding black holes and how they challenge our understanding of the laws of physics. So, sit back, relax, and get ready to learn about one of the most powerful and mysterious objects in the universe. What is a black hole? So, black holes are formed when a really big star runs out of fuel and collapses under its own gravity. The gravity gets so strong that even light can't escape, which is why they're called black holes. There are three types of black holes. Stellar black holes. These are the most common type and are formed from the collapse of a single star. Intermediate black holes. These are larger than stellar black holes but smaller than supermassive black holes. Supermassive black holes. These are found at the center of most galaxies, including our own Milky Way. Now, you might be wondering, how can scientists even detect something that can't be seen? Well, they actually look for the effects of black holes on other objects. For example, if a black hole is orbiting a star, the star will look like it's moving erratically, because the black hole's gravity is affecting it. Another way scientists can detect black holes is by looking for X-rays. When matter falls into a black hole, it heats up and releases X-rays, which can be detected by special telescopes. Properties of black holes. As we mentioned earlier, black holes have incredibly strong gravity. When a black hole is nearby, it can affect the motion of other objects around it. This is similar to how the moon affects the tides on Earth, but on a much larger scale. For example, if a star gets too close to a black hole, it can be pulled in by the black hole's gravity. The star will start to spin around the black hole, faster and faster, until eventually, it gets sucked in. This is called accretion. But it's not just stars that can be affected by black holes. Even light can be bent or distorted by a black hole's gravity. This is called gravitational lensing. To give you an idea of how strong black holes' gravity can be, let's take a look at a real-world example. In 2018, astronomers detected a black hole that was kicking a star out of our Milky Way galaxy. The star had gotten too close to the black hole and was flung away at a speed of over 3.7 million miles per hour. Measuring a black hole might sound like a daunting task, given that they're invisible and can't be directly observed. However, scientists have come up with some clever ways to measure them indirectly. One way is to measure the effects of a black hole's gravity on nearby objects. As we mentioned in our last video, black holes can affect the motion of nearby stars and even bend the path of light. By observing these effects, scientists can estimate the mass of the black hole. Another method is to look for X-rays emitted by matter falling into a black hole. As matter falls in, it heats up and emits X-rays. By observing these X-rays, scientists can estimate the size and mass of the black hole. A third method involves observing the movements of stars around the center of a galaxy. This is how scientists discovered the supermassive black hole at the center of our Milky Way. By tracking the orbits of stars around a central point, they can estimate the mass and size of the black hole. To give you an idea of how scientists measure black holes, let's take a look at a real-world example. In 2020, scientists announced that they had measured the mass of a black hole in a galaxy called NGC 3244. They did this by observing the motion of a nearby star, which was being affected by the black hole's gravity. By analyzing the star's movements, they were able to estimate the black hole's mass to be around 500,000 times that of the Sun. The mystery of black holes. Black holes are incredibly powerful and mysterious objects that challenge our understanding of the universe. They are one of the most extreme predictions of Einstein's theory of general relativity, which describes gravity as the curvature of spacetime. One way that black holes can change our understanding of physics is by helping us to test and refine our theories of gravity. Einstein's theory of general relativity has been incredibly successful in explaining the behavior of gravity in our solar system. But it breaks down when we try to apply it to the extreme conditions of black holes. By studying the behavior of matter and energy around black holes, scientists can refine our understanding of gravity and test alternative theories. Black holes can also help us to understand the fundamental nature of space and time. According to Einstein's theory of general relativity, time and space are intimately linked, and the curvature of spacetime is what causes gravity. But black holes are so extreme that they can warp spacetime in ways that we still don't fully understand. By studying the behavior of matter and energy around black holes, scientists can gain new insights into the nature of space and time. Black holes are incredibly powerful and mysterious objects that can have a significant impact on the surrounding space. They can affect the orbits of nearby stars, emit high-energy radiation, and even warp the fabric of spacetime itself. While black holes are fascinating objects to study, they can also pose some potential dangers. One of the potential dangers of black holes is their gravitational pull. Black holes have an incredibly strong gravitational pull that can trap anything that gets too close, including light. This means that if a star or planet were to get too close to a black hole, it would be pulled in and destroyed. This could have significant consequences for the surrounding space, as the loss of a star or planet could disrupt the orbits of other objects. Another potential danger of black holes is the high-energy radiation that they can emit. As matter falls into a black hole, it heats up and emits radiation, including X-rays and gamma rays. This radiation can be incredibly dangerous to living organisms, as it can cause mutations and damage to DNA. Fortunately, the high-energy radiation from black holes is typically limited to the immediate vicinity, so it's not a significant threat to life on Earth. The future of black hole research. Black holes are one of the most fascinating objects in the universe, and scientists have been studying them for decades. Despite all of the research that has been done, there is still so much that we don't know about black holes. But in recent years, there have been some significant advancements in black hole research that have provided new insights into these mysterious objects. One of the most significant advancements in black hole research has been the direct observation of black holes. In 2019, scientists captured the first ever image of a black hole, which was located at the center of the M87 galaxy. This image provided new insights into the way that black holes consume matter and the role that they play in shaping the galaxies in which they reside. Another area of active research is the study of gravitational waves. Gravitational waves are ripples in spacetime that are created by the movement of massive objects, such as black holes. In 2015, scientists made the first ever detection of gravitational waves, which were produced by the merger of two black holes. Since then, there have been numerous detections of gravitational waves, which have provided new insights into the behavior of black holes and the nature of gravity itself. Understanding these objects is not just an academic pursuit. There are many potential implications of black hole research that could have significant consequences for our understanding of the universe. One of the most exciting potential implications of future black hole research is the possibility of uncovering new physics. Black holes are incredibly dense objects that can warp the fabric of spacetime itself. Studying these objects could help scientists better understand the nature of gravity and the behavior of matter under extreme conditions. Another potential implication of future black hole research is the possibility of discovering new astrophysical phenomena. Black holes are known to emit high-energy radiation in jets of particles, and studying these emissions could help scientists better understand the mechanisms behind these phenomena. Additionally, studying black holes could help scientists better understand the formation and evolution of galaxies, as black holes are thought to play a significant role in shaping these structures. Thanks for joining us on this journey through the fascinating world of black holes. We've covered everything from how black holes form to the potential implications of future black hole research. But there is still so much more to learn about these mysterious objects, and we encourage you to continue exploring this topic on your own. If you enjoyed this video, please consider subscribing to our channel for more content like this. We're passionate about making science accessible to everyone, and we would love to have you as a part of our community. Also, feel free to leave any questions or comments you may have in the comment section below. Thanks for watching, and we'll see you in the next video.